In today's talk, I want to present the justification for the establishment of a planetary analogue research station here in Australia. In the talk, I will look at what is meant by planetary analogue research station, the reasons for having such a station in Australia, why have we selected the Arkaroola region for the station, then a quick tour of the Arkaroola region itself, and then finally, a discussion of the design concept that we have used. So what is a planetary analogue research station? They are field stations that provide a platform and a location for integrated activities related to planetary exploration. The sort of work that we've done there can include operational planning and concepts for planetary exploration missions, looking at habitat design and their operation, the planning of EVAs and their execution, a facility to test equipment and technology concepts, a place to carry out realistic field science such as astrobiology and astrogeology, a place to carry out human factor science, biomedical research in looking at environmental conditions, for example, within habitats, a place too where all of these activities can be integrated together for complex missions and to carry out education, research, and public engagement. There are many such stations either built or under development around the world. More are coming online, and all of them are to varying degrees Mars focused, as is the one we propose at Arkaroola. But a lot of the questions are similar whether we're looking at exploration on Mars or on the Moon. So why have such a facility in Australia? Well, first of all, it provides access for Australian researchers to do these sort of activities, particularly in the current climate of a global pandemic. Under more normal conditions, it also provides a facility that can be used by regional and global researchers, and particularly as it's the only major example of a facility built or planned in the Southern Hemisphere. And this means that the field season in Australia is the opposite to that of the Northern Hemisphere locations, most of which are in deserts or in the Arctic region. So, for example, we are able to run our stations in the Southern Hemisphere winter, whereas the Northern Hemisphere stations are normally, with the exception of the Arctic locations, run in the Northern Hemisphere summer. As a new facility, there's opportunity here to explore a unique design for habitats and to meet the growing international demand for analogue field stations. So why did we in MSA choose the Arkaroola region? There are a number of reasons. First of all, the Arkaroola region is accessible from Adelaide, a major city with international connections, at least under normal conditions. The owners and managers of the property, Arkaroola Proprietary Limited, are hospitable and supportive to our goals of science, education, and outreach. There's suitable support structure at the Arkaroola village for maintenance and repair and communications. The site has reasonable access over much of the region, either because the country is open or there is a network of rough tracks which can be used. From a safety perspective, medical evacuation is possible by the Royal Flying Doctor Service. There are multiple airfields which they can use within close proximity to our proposed station. And the landscape is barren for the most part, particularly on the plains to the east, and therefore more or less Mars-like. The terrain and geology is very diverse, as are sites of biological and astrobiological interest. Furthermore, the site we propose can be isolated with the cooperation of the Arkaroola management from the public for long periods of time, should researchers wish to carry out isolation studies, for example, in the area of human factors and operations. Lastly, there there are opportunities of linkage at Arkaroola to both the education and outreach activities by the Arkaroola community itself, both in terms of environmental sciences and astronomical sciences, and also to the Australian Space Agency's education outreach program at Lot 14 in Adelaide. So this is where Arkaroola is in the map of South Australia. Adelaide down south. Arkaroola itself is about a day's drive, 9 hours drive to up at the top end of the Flinders Ranges. Now, if we zoom in, we can see the Flinders Ranges at the northern end there, the folded Proterozoic and Paleozoic sedimentary rocks surrounded by low relief plains and chains of salt lakes. The red circle is a 100-kilometre radius surrounding the proposed site for the Marsoz station, and this corresponds with the 100-kilometre radius surrounding proposed landing sites on Mars for crewed missions. As you can see, there's a diversity of terrain there, from mountain ranges to salt lakes to plains. Now, if we zoom in further to the box, we can see just some of the diverse features of interest for Mars analog research or planetary analog research. We have hot springs, radioactive hot springs, both active ones at Arkaroola, and also extinct mineralized ones at Mount G. We have active fault scarps, diverse geology. Some examples there are the evaporites at Baranda Gorge. We have fresh Proterozoic basalt, also weathered Proterozoic basalt. We have mineralized fault structures, unconformities at Blue Mine, Proterozoic glacial deposits at Stubbs Waterhole, as well as dunes and various types of pediments and alluvial fans. For the paleontologically minded, there's also many horizons, many stratigraphic units that contain stromatolites. We have used the Arkaroola region already, even without a habitat, for a range of Mars analog research, for example, operational research involving the use of drones and people on simulated EVAs. We've also tested a range of small to medium-sized robotic vehicles in comparative trials. These vehicles are supplied by various institutions, mostly student-based, and we've been able to compare quantitatively their capabilities. On the top right, we have Marge Sprigg, one of the people who helped set up Arkaroola in the first place, acting as a guinea pig in assessing the ability of a trained geologist, such as herself, in being able to identify stromatolites in the field while wearing a simulated spacesuit. Here we have examples of some of the geological features in the area. On the top left, we have a bedding plane view of some of these stromatolites. In the top right, we have the Arkaroola hot spring, as it was a number of years ago. It's now shifted location from there, being part of an active system. And this system contains quite a complex microbial biota, some of which actually has radiation resistant genes, similar to those found in Deinococcus radiodurans. The bottom two photos are something that has had very little study. We see veins in a unit called the Tapley's Hill Formation in one of the gorges there, and microscopic study has revealed that these veins contain these small structures that look remarkably like fossilized bacteria. If they are that, then they represent fossils of a previous hot, deep biosphere in the Earth, back in the Proterozoic. If they're not, there are extremely good pseudofossils, and either way present a useful tool or feature to assess biogenicity in a Mars landlocked environment that can then be applied both to expeditions to the Martian surface and studies of Martian samples when they return to Earth. But these features have not had any further study, and they're just crying out for further investigation. Most of the rocks are sedimentary in the Arkaroola region, so you've got really beautiful ripple marks and sedimentary structures. On the top left there, Blue Mine, and on the top right we have stromatolitic limestones. But there are igneous-associated rocks. We have plugs of pegmatite in the bottom left there, and the bottom right we have the hematite quartz and cavity-filling sinter deposits of Mount G. Some really quite remarkable textures representing a cross-section through a fossil hot spring from a near-surface environment down to some depth. And there are also features in these sinters which are reminiscent of those that are formed by microbial activity, although the case is still out on these features, and they do need, once again, further study. For the station itself, the Marsoz station is based around a reasonably detailed Mars mission architecture that involves the landing of bent biconic modules on the surface of Mars. Here is a perspective view of the station itself, consisting of a habitat module, a garage that is docked onto the rear of it, and a separate cargo module that houses generators, alternatively batteries, and as a node for solar power systems. These modules would, in our concept, be prefabricated in Adelaide. They would have detachable wheels attached to them, and they would be towed up behind a prime mover to the field site, whereupon they would be set up as separate low impact modules on the desert floor in Arkaroola. This is a view inside the habitat module. There's a lot of detail there, but basically the upper deck is for living and clean working environments, office space, mess galley, sleeping areas, and the lower deck is for laboratories, medical areas, workshops, hygiene facilities. And the modules are 18 meters long and 4.7 meters in diameter. This is the second module. You can see it comes apart into a separate garage and also the forward half, which is the support module for the power supply, waste disposal, and so on. But otherwise, apart from this ability to attach into two halves, it's dimensionally identical to and structurally identical to the habitat module. Here we see the garage module docked on to the rear of the habitat module, showing additional workspace for the crew. The station is designed to accommodate up to 8 people in a simulation mode. It could also be used to accommodate more if you're using it as a remote classroom facility. We have built a full-size mock-up of a segment of the station back in 2017 at NASA Ames. On the left there is the upper deck showing the position of cabins. And on the right there, we have a segment of the lower deck, which would shows the amount of room available for laboratories and workshops, both vertically and laterally. So we are open for discussion about the station, about the design, the suitability of the area, why we chose it, and any other factors. So please feel free to contact us. Thank you.